I think the next time I send a bio and it's just going to say he's been around a long time, so it'd be a lot easier. So what I'm going to do is I'm going to talk about constructing tomorrow's infrastructure, but I'm not going to do what you would expect in a typical engineering presentation. I'm not going to talk about concrete and steel. I'm going to not talk about means and methods of construction, although I will tell you I'm very happy to do that at some great length, but I don't think that's really the forum today. So when I look at infrastructure, I think it's very important to make a couple opening statements to frame how I kind of see infrastructure. And the first is infrastructure is an enabler. It's an enabler of everything that society does. It shapes the development of society, and in turn, it's shaped by those developments. It's a way to connect not only space, but also time. These are long-lived assets, and they shape how society itself evolves. A notion that I thought you were getting at a little earlier in some of your comments was it's really a system of systems. And I think that's a very important framework as we look forward. But it's also a slow adopter of changing technologies. This is probably one of its biggest challenges. But when it does adopt those changes, the impacts are highly, highly significant. So with that, let me kind of get into it. On the left is a little graphic illustration of our infrastructure gap, what our needs are, and what the current funding profile looks like. Senator Warner talked. Well, first of all, it was really great to hear a congressional leader able to talk about infrastructure for the amount of time he did. I mean, I'm really impressed by that alone, and talk about it intelligently. So I thought that was good. But you know, a lot of his comments, not all, but a lot of his comments went to the funding side, and that's not unusual, particularly here in Washington. And that's about bringing more money into the system. But the graphic on the right really, I think, goes towards what it will take to close the infrastructure gap going forward. It's going to take a set of policy actions that tend to bend that upper curve. It's going to take some new funding, and it's going to take a very changed focus in how we look at our assets and think about them not in terms of just the first cost of those assets, but really a life cycle cost. We need to reduce, on average, the life cycle cost of our infrastructure by about 50% in order to intelligently close the gap in infrastructure. Now, a group that I'm involved with, which is the Industry Leaders Council of the American Society of Civil Engineers, and we provide advice to the ASCE Board of Direction. And we made a recommendation to them about 3 years ago that they adopt a grand challenge to reduce the life cycle cost of new infrastructure by 50%. And you had to see the faces when we recommended it. The jaws all dropped. And one guy just couldn't contain himself. He blurted out and said, "We can't do 50. The best we can do is 30." And that's when we knew we had them. So they'll roll out that and some supporting actions next month, actually. So what I'm going to do is talk about looking at infrastructure and dealing with this infrastructure gap from three important ingredients. Framing what the problem is, because I think there's a lot of belief that we know what the problem is, but I'm not sure we all agree what the problem is. So this notion of starting to frame the problem, funding the problem because money is an issue, and then finally fixing the problem. So let me start with framing the problem. So the first is how we go about picking the projects that we're going to do, okay? Right now, many of those projects fall in a political process, and to say that rational selection is a hallmark of that process would be a gross overstatement of reality. Second is to recognize the fact, and this is really shocking, 2 out of 3 large projects fail, okay? So the normal condition of an infrastructure project is failure. Success is a rarity. It's an exception to the norm, okay? I want you to think about that. If everything you did in life, if the things you did in life, if 2 out of 3 times you tried to do something, you failed, I don't think you'd be feeling very good about it. But somehow we do. Construction productivity in the United States stinks. It has not grown, has not improved in the last 40 years. Okay? Compare that to all non-farm industries as a group, and the gap is huge. This is a major economic drag, and quite frankly, it's a major embarrassment to how we undertake these projects. The assets we have aren't really understood. They're not valued. And quite frankly, they're not even tracked. I'm working with one client now. I guess I could say it. It's the MTA in New York. And that one agency's assets, infrastructure assets, have been valued at $1 trillion. So when you think about the installed value of our infrastructure systems nationally, and then you look at the replenishment rate that we're looking to reinvest in these assets, they better have 200- and 300-year lifetimes, because on any other economic basis, we would be significantly underinvesting in the replacement, and we are. Okay. The focus right now is on ribbon cuttings. State of good repair is when the hole appears in the deck of the bridge and it falls into the river. That's not the infrastructure that this country requires. We need a life cycle perspective. So my profession, the engineering profession, has for years banged the drum, for decades, banged the drum on the need for more money. But yet, the point a number of us have been trying to make is we have more control over the outcome than we recognize. If we change our prescriptive design specifications to life cycle-based performance specifications, we will drive a change, and we'll drive a change in funding, not just in how we design things. So as I go through the balance of the presentation, and I forget who I was talking to this morning, but I liked his words, so I'm going to use it. It's not about doing big things. It's about a series of small nudges to the process, small changes in a lot of different areas that can make a huge, huge difference. So let me go on to funding. Okay, and there was something that Senator Warner said that I thought was not only spot on, but very unusual to hear, and that is funding and financing are often confused. It's often assumed that if we can finance the projects, we're done. We can check the box, we're done. But you do have to pay the money back. That, by the way, is not a normal notion when it comes to infrastructure. And it's the reason why we run our infrastructure into the ground. We have a distortion in the United States that does not exist elsewhere in the world, and that's municipal tax-exempt financing. Now, on one hand, it lowers the apparent cost of financing, understanding that in effect it's a subsidy from the federal level to the municipality in the form of financing. But second, it keeps a major source of long-term capital out of the infrastructure market. And that source of long-term capital are pension funds, which by their very nature are tax-exempt institutions and have no need for tax-exempt financing. In fact, it penalizes them from an investment standpoint. So I'll suggest something fairly heretical, which is maybe eliminating tax-exempt financing and dealing with the true cost of infrastructure would be a better solution. The muni industry at this point is up in arms if they hear that statement, but maybe that one sector of the U.S. economy needs to be in tune with all other sectors of the global economy, which is a taxable finance regime. There's some other reasons for that, and that has to do with covenants. In simple terms, as a firm that does P3s, if we go to the debt markets, we have covenants that say, oh, by the way, we're giving you this money, but keep the asset in a state of good repair. And that's defined at great length. If I go out for muni debt to build a new road, there is no state of good repair covenant. So not only do we have a financing disparity, we have a covenant disparity. And in effect, in the private model, the P3 model, we're incentivized to think about life cycle to maintain the asset, where in the municipal context, we're incentivized to build as much as we can and forget about the maintenance of it, which we do. One is politically attractive, the other less so. Our tax policy also doesn't recognize the nature of these assets. So, capital gains, short-term, long-term, I think it's 1 year. So once you've gotten to 1 year, you're in a long-term capital gain rate situation, very attractive compared to short-term. But here we're talking about assets that want to have 5, 10, 20, 30, 40, 50, 75-year asset lifetimes. And we really like to see buy and hold investors, owner-operator investors that have come into these assets for 30, 40, 50, 75 years. And maybe we can use tax policy to incentivize that, to incentivize the fact that the longer one holds an asset, maybe the lower the capital gains tax rate is, as long as you do certain other things with that asset. Okay. So let me just touch on one last point here, and that's on post-disaster rebuilding. Disasters are a fact of life, whether it's global climate change, 9/11 events, Katrina's. The one thing we know about Mother Nature is that she behaves in catastrophic ways. Okay, that normal distribution doesn't hold when we look at the impact of events on our infrastructure. It's a catastrophic distribution. And when we looked at our current policy, and it changed a little bit with Hurricane Sandy, the policy was there was federal support for rebuilding in kind. So the thing that just failed, we would rebuild it so it would fail again under a similar event. We need to build back better. That requires a permanent change in law and policy and regulation. So let's go on to fixing the problem. And what I'm going to do is I'm going to lay out fairly quickly 10 significant opportunities really to fix some of the problems, build our infrastructure better. And so the first one of those is to really develop some robust standards on infrastructure prioritization. It is not unusual for me to sit down with a large capital program owner, maybe with 20, 30, 40, $50 billion of infrastructure capital program, who says, how do I decide where I should put my next dollar of investment? And those of you on the academic side, I'm going to tell you the research is not well developed. The prioritization criteria to be considered are not well developed. And the multi-factor analysis capabilities, while mathematically well developed, haven't been really applied into this space. And I think there's a huge opportunity there. And then also looking at these things from a portfolio standpoint, because these are not all new investments. There's some really mundane things like state of good repair and dealing with the fact that you want to be investing in innovation, if you will. So there is much to be done there. And we have to ensure that we're doing the right projects, or we'll never close that infrastructure gap. The second is strategic management. Now, this is something that I think next week or the week after, I'm going to spend about 3 hours talking to a large group out in Las Vegas about. But the bottom line is, I'll go back to the point on 2 out of 3 large projects failing. And the simplest way to describe this is the theory of project management was developed back at the industrial age, when project management was applied within the 4 walls of a factory. Okay, it was bounded in time and space. It was pretty straightforward. And the analogy I like using, it was kind of like Sir Isaac Newton and Newtonian physics. F equaled ma, the world was fine, everybody understood it. And along came Einstein and said, I want to talk about the universe, and found out that Newtonian physics didn't scale. And so we came up with new physics. And it's not that one is right or one is wrong, it's that they're different and they apply in different realms. Right now, our practices in large project management, not just in the infrastructure space, but across all market sectors, is failing us. And 2 out of 3 large projects failing consistently, despite our best practices, says that maybe we're solving the wrong problems, if you will. I'll go on from there. So the next thing is we have to build for the life cycle, okay? And really a very simple thing. What happens today is owners say, well, I want a project that does this. And that this is more often than not a technical description. I want a bridge with 3 lanes that goes from here to there and, you know, that kind of thing. And the owner gives those project requirements to an engineer. The engineer is really smart guy. He turns them into saying, well, that means it's got to be 6 inches thick and 12.2 feet wide and 8 feet high, or you know, whatever it is. And then along comes the contractor to build it. And of course, it's not designed to build efficiently. And so one of the things we see with P3s in the United States and more broadly now is more of a focus on design build where there's an expanded basis of design. And I'll just give you one example. So the poster child for me is the ongoing Tappan Zee Bridge in New York, which we're doing. We brought the owner wrote a very good performance specification. We brought the designers in at the bid stage. We told them, here's how we want to build the bridge. And they walked out of there designing a very, very different bridge than they would have coming in. And the result was they took $400 million of cost out of the bridge. Functionally, the bridge does exactly the same thing, but their mindset was very different because we had some different approaches to building the bridge. And the same thing with bringing in that operating and maintenance definition. We need to go much more into manufacturing approach than a stick-built, bespoke approach on project after project. We're seeing trends in that happen. Utah with their bridge farms for standard highway bridges. The projects that we did in San Francisco, the San Francisco Oakland Bay Bridge and the one on Tappan Zee, basically we were building large prefabricated sections elsewhere and then bringing them to the project site. So we're building a grade instead of over water. In the case of Tappan Zee, the first set of beams that we placed were actually the most complex on the bridge. They were built upriver, significantly upriver from the project site. We had a crane that allowed us to lift 1,200 tons of girder. Length was over a football field long, and it really accelerates the construction process when you can move big things and build them in much more of a manufacturing setting. Removing the handcuffs. There are all kinds of rules that work against efficiency in our infrastructure systems. I'm going to give you just 2. So back in the 1950s, as the interstate highway system was building out, there was really good notional idea at that time, which was that we really wanted this interstate system to be very dynamic, very supportive of our economy, and we didn't want other things cluttering it up and getting in the way. And so we said at the time that you cannot put other linear infrastructure into a national highway system right away, okay? Yet today, the cost of assembling linear infrastructure is prohibitive in most instances, and the single best corridors for other infrastructure systems, transmission lines, gas pipelines, rail lines, is in these very same infrastructure corridors. And you'll see in various places around the world this look at multi-use corridors. And yet in the United States, by law, you can't get on the very pieces of infrastructure which go to exactly where you want them to go. So we work very hard. The other one is after 9/11, there was an interest in improving security and having new ways to improve security. And you had all the product liability concerns that came into consideration at the time. And the US government put in place what was called the Safety Act. And it said, hey, if you come up with something that meets these kind of criteria about improving security of the nation, then we're willing to provide you tort protection from a product liability standpoint. I think a comparable type of limited protection in the infrastructure sector would allow the experimentation on new materials, new technologies, new equipment at a rate that would make a huge economic difference. And quite frankly, I think a huge difference to society, if you will. We don't value time. Infrastructure projects are measured in decades or generations to come to fruition. Okay, decision-making time is viewed as free. Okay, I mean, I've seen owner after owner, it takes another 3 years to make a decision and wonders why his budget from 3 years ago is no longer good. Okay. Or you're out in the middle of construction, something comes up and he has to approve a change, and he goes into a 6-month process when it should be about 6 minutes of effort when you look at the value of the change, if you will. So these are all important things. I think also the notion of one-stop permitting. We take way too long. We have demonstrated what we can do when we go to one-step permitting at the federal level. We saw that with the Tappan Zee Bridge. We saw it with others. Tappan Zee Bridge, 12 months more or less of federal permitting activity versus what probably would have been 6 or 7 years. So it is possible, and you don't have to do it for everything. If we can agree on what critical infrastructure is, that would be a good first step. So post-disaster, I talked about Mother Nature being catastrophic in nature, not normally distributed in nature. And what that means is we need to be prepared to deal with the fact that we will be constructing in significantly impacted or destroyed environments. And the problem is all of our rules, regulations, approval processes are set up for business as usual, and yet the cost of delay, both human cost and financial cost of delay post-disaster is very, very significant. We need to recognize that disaster is a normal occurrence, not an abnormal occurrence. And if you look, the frequency of large-scale disasters and the associated economic impact has been steadily increasing for the last couple of decades. Okay, so let me talk about a couple other things that I think are important but heretical. So I talked about the fact that the industry wasn't particularly innovative and didn't really improve its productivity. Part of that's due to the industry structure. So when you look at large manufacturing, there are major players with major market shares and that have supply chains that they're able to orchestrate to move together to really drive systemic innovation. In the United States, there's over, I think it's 130,000 engineering and construction firms. Nobody has a 1% market share. Supply chains are something that are new. The notion of a permanent supply chain is almost impossible in the U.S. context for many reasons. And yet we need to find ways to create more robust, both horizontal and vertical supply chains. And then U.S. industry has a lot to gain by servicing infrastructure outside the United States, because quite frankly, we learn new things when we do that. But right now, tax policy makes it prohibitive for us to deploy U.S. engineers overseas. They're effectively double taxed. Cost of a U.S. engineer overseas could be 3 or 4 times a British or Australian engineer's cost around the world. And that drives us towards the outsourcing of engineering, whether that's hiring others than U.S. engineers for these projects, or actually doing more and more engineering outside the United States, neither one of which are good for this country on a longer term basis. We need a new financial construct. I've talked about, eliminating tax-exempt financing to open up access to the pension funds, a reward for longer-term investments. The senator did talk about this subordinated, I use the term infrastructure bank. It's a financing vehicle, whatever you want to call it. It's TIFIA on steroids, those of you familiar with TIFIA. It's a good thing that we could use more of. It's agreed that it is a good thing, but we can't seem to get more of it in any meaningful way. So I'm really encouraged by what the senator said. And then I've already talked about the covenant point as well. Resilience is part of the focus of this concept. And really what that means is thinking about how we're going to recover. Right now, the federal government is acting as the insurer of last resort without declaring itself to be so. If it was the insurer of last resort and declared itself to be so, it could drive through policy, reinsurance type policy, the primary insurers to require a level of resilience in basic businesses. We see this in the business continuity area in the private sector, but much more can be done. I'll also say that it's not just about, I think this is the next slide. Yeah, it's not just about concrete and steel, but it's very much about having in place operating frameworks. I co-chaired an infrastructure task force in New York after 9/11, when multiple infrastructure systems were all stressed to failure by the same event at the same time and recovered in very, very different ways. And I think understanding why they recovered had more to do with organization and management, cultures and processes, decision-making processes, than it had to do with the condition of the infrastructure itself. So not to lose sight of the importance of the soft issues. I think we need a new infrastructure paradigm. I'm not going to read all that to you, but basically we need to consolidate and prioritize. We need to manage really on an enterprise or portfolio basis. We don't invest in R&D in this space. Okay? We don't invest in R&D because it's too risky to deploy it. And hence, we have no productivity improvement for 40 years. Okay? So something's broken, but it's broken in a way that's very fixable, in my view. And then finally, monetizing it. I made the reference to the $1 trillion in one asset, in one owner. I don't know. I have no clue what the value of the nation's infrastructure assets are. But if we had a report on the value of those assets and how they've depreciated or appreciated every few years, I think we would start acting very differently towards our infrastructure system. So this, unfortunately, is what some of our resilient infrastructure looks like. The goal, that's all rebar, by the way. The goal is to get concrete in between there. The reality is, it's not just the physical hardening that's required. It's really about those system hardenings. So on your, whoops, now how do I go back? There I go. Okay, so on your tables, and I'm going to close with this, there's some thumb drives. On the thumb drives is my presentation, but there's also electronic copies of 2 books that I was co-author on most recently on resilience. I thought they were appropriate for this conference. One deals with planning for natural disasters, and then the other one looks at how the engineering and construction model changes post-disaster. The whole response phase is not really covered here, but I did want to make one point, which is in the 21st century, yes, police and fire and medical are all first responders, but in today's growing urban environments, engineers and constructors are first responders too, and not covered by Good Samaritan legislation. Thank you.